here you wanted to learn about measuring disease frequency. So there are a few definitions we need to take a look at, which include population at risk, incidence, prevalence, and we'll see how these interact. Come on, let's check it out.
Population at risk. These are the people who are susceptible to a given disease and can be defined by demographic, geographic, or environmental factors. For instance, if this is the total population and men make up half the total population and women make up the other half of the total population, men should not be included when calculating the frequency of uterine cancer as they do not have uteruses. Since risk factors are not present immediately, women below 24 years old are not included in the population at risk. Same goes for those who are more than 70 years old. So for the population at risk for uterine cancer, those in the reproductive years of 25 to 69 will be included. Let's take an example of uterine cancer during a given year. The incidence of disease represents the rate of occurrence of new cases arising in a given period in a specified population. So the numerator would be the number of new cases and the denominator would be the population at risk as discussed earlier. Let's say there is 4 new cases over 10 population. We would multiply that by 1,000 to get our incidence rate for the year. What's critical for incidence is that every person in the denominator must have the potential to become one of the people in the numerator. If these 4 people were part of the denominator and transitioned from disease-free to diseased, they become part of the numerator. Let's also say, for example, if 3 women of our population at risk had their uterus removed, they would no longer be a part of the population at risk because they do not have the potential to become part of the numerator. So instead of, let's say, 4 out of 10 in our example, it would now be 4 out of 7 for the population at risk times 1,000, and this equals a new incidence rate of 570 per 1,000 population. Case fatality is a measure of disease severity, and it is defined as a proportion of cases with a specified disease or condition who die within a specific time. It is usually expressed as a percentage. The numerator is the number of deaths from diagnosed cases in a given period over the number of diagnosed cases of the disease in the same period times 100 for the percentage. Prevalence is the frequency of existing cases in a defined population at a given point in time. Our numerator would be the number of existing persons affected with the disease at a given point in time over the population at risk times 1,000. And what's the difference between incidence and prevalence? Let's take a group of 5 people who develop a disease over a period of 6 months. One develops the disease in January, 2 in February, 1 in April, and 1 in June. Ignoring the denominator for now, the incident cases or the new cases in January, for example, would be 1, February would have 2, March would have 0, in April we would have, and May we would also have 1. Now prevalence also takes into account the duration of the disease. Let's say case number 1 is cured in May, case number 2 is cured in June, case number 3 is cured in April, and case number 4 and 5 during the second half of the year. Let's look at the numerator for prevalence of the disease, which would be the number of existing cases at a given point in time. Again, let's focus on the numerator during each month. We have 1 case in January, 3 cases in February, 3 cases in March, 4 in April, 3 in May, and June. So prevalence is determined by how many people join the prevalence pool or the incidence, and how many leave the prevalence pool through death or cure. Let's say that all the pebbles in this container is included in the total population at risk. Each incidence is a pebble added to the container, and should someone die from the disease or if they are cured, a pebble leaves the container. So if death goes up, then more people will leave the container. If death goes down, then more people will stay in the container. Let's say this is our baseline. What happens to prevalence if incidence goes up while the death and cure stay the same? The prevalence will also go up. But what if death and cure go up but the incidence stays the same? Prevalence will decrease as more pebbles will leave the container. So prevalence is a measure of disease burden, and it is a great tool for planning the allocation of health services. Prevalence is incidence times duration, and duration is determined by the death rate or the cure rate. Let's use the example of our uterine cancer disease in two different populations in Cubao. One is the population of New York, and the other population is in San Francisco. We'll say New York has a prevalence of 50 cases per 1,000 population, and San Francisco has a prevalence of 10 per 1,000 population. So, to the person who's not familiar with the fact that prevalence is not a measure of risk, but rather a measure of the burden of the disease, it looks like New Yorkers are at an increased risk to develop uterine cancer. But we should know this is not true. If we look at the incidence rate and the duration of the disease in these locations, where incidence rate is 5 per 1,000 per year in both locations, but the duration of disease is 10 years in New York due to better care, whereas in San Francisco people die from uterine cancer after 2 years, the higher prevalence in New York is just an expression of better care of an incurable disease. We said prevalence is equal to incidence times duration, so 5 times 10 is 50, and 5 times 2 is 10. I hope the difference between incidence and prevalent is a bit clear.